Hi everyone! Do you remember? Points are most often considered within the framework of Euclidean geometry, where they're one of the fundamental objects. This is a point. A line is formed when a point is moving. The shortest distance between 2 points is a straight line. A plane is formed when a line is moving. Edges of planes are lines. The intersection between two planes also forms a line. Solids are formed by planes. Now let's discuss the relationship between points, lines and planes. First, let's talk about the distance between a point and a line.
Here is a point P. P is not on the straight line L. How do we find the distance between point P and the straight line L? If we construct a straight line passing through point P and point P pi, such that PP pi is perpendicular to L, then the length of PP pi represents the shortest distance from P to L. This length is called the distance between point P and the straight line L. Here is a 3D figure. The distance between point A and the straight line FG is AF. It is because AF is perpendicular to FG. Therefore, the distance between point A and straight line FG is 3 centimeters. The distance between point A and the straight line BC is AB, because AB is perpendicular to BC. So the distance between point A and BC is 4 centimeters.
Next, let's discuss the distance between a point and a plane.
Here is a point P and a plane pi. What is the distance between point P and the plane pi? In the figure, P is a point outside the plane pi, and P pi is a point on plane pi. If P pi is perpendicular to every line on plane pi which passes through P pi, then P pi is the projection of P on the plane pi. The length of PP pi is the distance between P and the plane pi. Let's look at this 3D figure again. How do we find the distance between point A and the plane BCHG? We must first find the projection of point A on the plane BCHG. Since AB is perpendicular to BC and AB is perpendicular to BG, therefore point B is the projection of point A on the plane BCHG. We say that AB is the distance between point A and the plane BCHG. Point D is the projection of point A on the plane CDEH. AD is the distance between point A and the plane CDEH. Similarly, point F is the projection of point A on the plane GFEH. Then AF is the distance between point A and the plane GFEH.
Now let's discuss the distance between two straight lines. Here are two parallel lines, L1 and L2. They lie in the same plane, but they will never intersect at a point nor form an angle. These two parallel lines keep a constant distance. If AB is the distance between the two parallel lines and AB is C units, then the distance between the two parallel lines is C units. If two straight lines are not parallel to each other, they intersect at a point. The point where two straight lines intersect is called the point of intersection. The angle theta formed between two intersecting lines is called the angle between the lines. In practice, an acute angle is used for the angle between the lines.
This is a cuboid. Straight line AB and straight line CD are parallel to each other. Straight line AD is perpendicular to AB, as well as to CD. Then AD is the distance between straight line AB and straight line CD. Straight line AB and straight line FG are also parallel to each other. Straight line AF is perpendicular to AB and FG. Then AF is the distance between straight line AB and straight line FG. Straight line DK and straight line FE intersect at point K. Point K is the point of intersection, and angle DKE is the angle between the lines. Moreover, straight line AB and straight line EH are parallel to each other. We may observe this 3D figure in perspective. A straight line XY is constructed. XY is perpendicular to AB and EH. xy is the distance between AB and EH. The length of xy can be found. Pythagoras' theorem may help. Xy squared is equal to py squared plus xp squared. The length of py is fe, and the length of xp is af. Through substitution and evaluation, the length of xy is found.
In the following section, let's discuss the relationship between a straight line and a plane. There is a straight line L and a plane π. If they intersect at a point, this point is called the point of intersection. Line segment OQ is the projection of line segment OP on the plane π. The angle theta formed between OP and OQ is called the angle between the line L and the plane π. One point should be noted. When the angle between a line and a plane is equal to 90 degrees, the projection of the line L on the plane π is just a point O. Meanwhile, line L is perpendicular to every line on the plane π which passes through point O. We say that the line L is perpendicular to the plane π. Some guys may find it difficult to find the angle between a line and a plane. Let me share my experience.
To locate the angle between a line and a plane, first, locate a point on the line segment which is near the plane. Then produce a straight line until it touches the plane and a point of intersection is formed. Second, construct a straight line at the other end of the line segment. The constructed straight line should be perpendicular to the plane. This perpendicular line intersects the plane at a point. Join this point and the point of intersection together. The projection of the straight line on the plane is formed. A right-angled triangle is formed by these three straight lines. That is, the original straight line, the perpendicular line, and the projection. The degree of the angle between a line and a plane can be found by applying trigonometric functions. Here is a cube. Let's find the angle between line BE and the plane EFGH. First, let's find the point of intersection. In this cube, BE touches the plane EFGH. Point E is the point of intersection. A straight line from point B is constructed. It is perpendicular to the plane EFGH. BG is this perpendicular line, and GE is the projection of BE on the plane. Angle BEG is the angle between line BE and the plane EFGH. Here is another cuboid. Point P is the midpoint of DC. Let's find the angle between the straight line PG and the plane BCHG. Point G touches the plane BCHG. Point G is the point of intersection. PC is perpendicular to plane BCHG. Then CG is the projection of PG on the plane BCHG. Angle CGP is the required angle between the line and the plane. Here is a right prism. What is the angle between the straight line BD and the plane CDEF? Point D of BD touches the plane CDEF. Point D is the point of intersection. A straight line from point B is constructed. It is perpendicular to the plane CDEF. Don't be mistaken, BC is not perpendicular to the plane CDEF. Yet, BF is perpendicular to the plane CDEF. DF is the projection of line BD on the plane CDEF. Angle BDF is the required angle between the straight line BD and the plane CDEF. Look at this 3D figure. ABCD is a rectangle. Point M is the midpoint of line AD, and N is the midpoint of line BC. If VM is perpendicular to the plane ABCD, let's find the angle between the straight line VA and the plane ABCD, the angle between the straight line VB and the plane ABCD, as well as the angle between the straight line VN and the plane VAD. Since VM is perpendicular to the plane ABCD, point A is the point of intersection between the line VA and the plane ABCD. AM is the projection of VA on the plane ABCD. Angle VAM is the required angle between straight line VA and the plane ABCD. Point B is the point of intersection between the straight line VB and the plane ABCD. BM is the projection of VB on the plane. Angle VBM is the required angle between the straight line VB and the plane ABCD. Since M is the midpoint of AD and N is the midpoint of BC, NM is perpendicular to AD, NM is also perpendicular to the plane VAD. Point V is the point of intersection between the straight line VN and the plane VAD. VM is the projection of VN on the plane. Angle NVM is the required angle between the straight line VN and the plane VAD.
Previously, we have discussed how two straight lines parallel to each other will never intersect. Similarly, two planes that are parallel to each other do not intersect either. When two planes are not parallel, however, they will intersect.
When two planes intersect, they intersect at a straight line. This straight line is called the line of intersection. These two intersecting planes make an angle. This angle is called the angle between two planes. In this figure, AB is the line of intersection between plane alpha and the plane beta. Theta is the angle between the two planes.
I guess you may be interested in finding the angle between two planes. Let's discuss this now.
Here are two planes, alpha and beta. They intersect at the line AB. Choose any point P on the line AB, that is the line of intersection, and construct a line PQ on the plane alpha such that PQ is perpendicular to AB. Next, construct a line PR on the plane beta such that PR is perpendicular to AB. Look, there are two lines perpendicular to AB. They are PQ and PR. Line PQ and line PR form an angle RPQ. Angle RPQ is the angle between the two planes alpha and beta.
In order to find the angle between two planes, it is necessary to locate the two arms of the angle. These two arms are lines which are perpendicular to the line of intersection. These two lines are constructed from the two planes respectively.
Here is a cuboid. Let's find the angle between plane ADEF and the plane ABCD, as well as the angle between plane FBCE and the plane ABCD. Let's look at plane ADEF and plane ABCD. These two planes intersect at line AD. On plane ADEF, ED is perpendicular to AD. On plane ABCD, CD is perpendicular to AD. Angle EDC is the angle between plane ADEF and plane ABCD. Next, let's look at plane FBCE and plane ABCD. These two planes intersect at line BC. On plane FBCE, FB is perpendicular to BC. On plane ABCD, AB is perpendicular to BC. Angle FBA is the angle between plane FBCE and plane ABCD. Now, let's look at this 3D object. The base ABCD is a square. VA, VB, VC, and VD are all equal. DP is perpendicular to VC. BP is perpendicular to VC. M is the midpoint of line AB. N is the midpoint of line DC. Please find the angle between plane VBC and plane VDC. Also find the angle between plane VDC and plane ABCD. Plane VBC and plane VDC intersect at the straight line VC. VC is a line of intersection. Since DP is perpendicular to VC, and BP is perpendicular to VC, DP and BP are the two arms of angle DPB. Angle DPB is the angle between plane VBC and plane VDC. Plane VDC and plane ABCD intersect at line DC. DC is a line of intersection. Since VC is equal to VD, N is the midpoint of CD. Then VN is perpendicular to DC. ABCD is a square. M is the midpoint of AB. and N is the midpoint of DC. Thus, MN is perpendicular to DC. VN and MN are the two arms of angle VNM. Therefore, angle VNM is the angle between plane VDC and plane ABCD. Here is a regular tetrahedron. Point P is the midpoint of AB, and point Q is the midpoint of CD. Can you find the angle between plane ACD and plane BCD? Also, what is the angle between plane ABC and plane ABD? This regular tetrahedron is formed by triangle ABC, triangle ABD, triangle ACD, and triangle BCD. They are all equilateral triangles. The 6 sides of this regular tetrahedron are all equal. Plane ACD and plane BCD intersect at line CD. CD is the line of intersection. Q is the midpoint of CD. In triangle ACD, AQ is perpendicular to CD. In triangle BCD, BQ is perpendicular to CD. AQ and BQ are the two arms of the angle of intersection. Angle BQA is the angle between plane ACD and plane BCD. Plane ABC and plane ABD intersect at line AB. AB is the line of intersection. Point P is the midpoint of AB. In triangle ABC, CP is perpendicular to AB. In triangle ABD, DP is perpendicular to AB. CP and DP are the two arms of angle DPC. Therefore, angle DPC is the angle between plane ABC and plane ABD. Last, let's apply our knowledge and skills in geometry to solve a 3D problem. Here is a regular pyramid. The length of the base is 8 centimeters. The length of the edges of this pyramid is 12 centimeters. Point P is a midpoint of CD. Let's find the distance between point V and the plane ABCD. Then find the angle between plane VCD and plane ABCD. Give all answers correct to 3 significant figures. The base of a regular pyramid is a square. Triangle BCD is a right-angled triangle. Let's apply Pythagoras' theorem. The length of BD is 8 times the square root of 2 centimeters. Point M is a projection of point V on the plane ABCD. BM is equal to MD. MD is half of BD. Therefore, the length of MD is 4 times the square root of 2 centimeters. VM is the distance between point V and the plane ABCD. Now let's calculate the length of VM. For the right-angled triangle VMD, the length of VD is 12 centimeters. The length of MD is 4 times the square root of 2 centimeters. By applying Pythagoras' theorem, the length of VM is 10.6 centimeters. Then let's find the angle between plane VCD and plane ABCD. Plane VCD and plane ABCD intersect at line CD. CD is the line of intersection. VP is perpendicular to CD. MP is perpendicular to CD. VP and MP are the arms of angle VPM. Hence, angle VPM is the angle between plane VCD and plane ABCD. Point P is the midpoint of CD. Join V and M. A right-angled triangle VPM is formed. Previously, the length of VM was found. It was 10.6 centimeters. MP is half of BC, so the length of MP is 4 centimeters. Applying the tangent function, tangent angle VPM is equal to VM over MP. Angle VPM is equal to 69.3 degrees. The angle between plane VCD and plane ABCD is 69.3 degrees.
In this program, we have discussed the relationship between points, lines, and planes inside a 3D object. If we can master these relationships and use perspectives to read 3D figures in detail, learning about 3D figures and related knowledge can be fun.